Hello, welcome to our Module 1, Lesson 5 of our CASP Plus course. On this lesson, we're going to talk about the following, such as virtualization strategies, cloud deployment models, hosting models, service models, and storage models. All right, so with virtualization, right, the underlying hardware can be completely abstracted from the program that uses it. So using just a thin layer of code, it controls access to all of the system's resources such as networking, CPU, storage, and memory. It's possible to operate a virtual machine on top of a software layer for almost any type of computing node. It's known as the hypervisor. Virtual machines include user desktops, email servers, directory servers, switches, firewalls, and routers. With virtualization, the data center may be more flexible, faster to deploy, and expandable as workload grows. As an added bonus, a company's data center footprint is minimized, such as less hardware or reduced power, and so on. So in virtualization strategies, we have what we call as a hypervisor. A hypervisor, right? It's actually in here. Is a layer of software or hardware that allows multiple operating systems to run on the same machine without interfering with each other. There are two types of hypervisor. First is type 1, and the other one is type 2. So what's the difference? For type 1 hypervisors, native hypervisors are software that runs on hardware platforms. The guest operating system is layered on top of the hardware on a separate layer. To run non-sensitive instructions at full speed, these hardware-bound virtual machine emulators rely on the real underlying CPU to run at full speed. Guest operating systems can be run on virtual servers or virtual hardware that looks and feels almost identical to the physical hardware that they're actually running on, and that's thanks to a hardware virtualization. Because the virtualized operating system has no idea it is being virtualized, no changes are necessary. Operating systems instructions are related and cached on the fly by the hypervisor, while user-level instructions run at their original speed. As an example for Type 1 hypervisor, we have VMware ESXi and Citrix Send Server. Now, what is a Type 2 hypervisor? A Type 2 hypervisor, also known as a hosted hypervisor, here, right, is a software that runs in an operating system environment, here, where the guest operating system runs at the third level above the hardware. An operating system that is already running can be used to run a Type 2 hypervisor. As a result, operating systems running on the hypervisor are referred to as guest or virtual machines. Rather than using hardware, this type of virtual machine is entirely software-based. A virtual machine emulator will be one of the applications that can be launched by the host after it has booted to completion. Examples of Type 2 hypervisors are VirtualBox and Microsoft Virtual PC. So what are the security considerations for virtualization? When an attacker bypasses the hypervisor by means of a guest operating system, this exploit is known as VM escape. This threat is so serious that vendors such as VMware and Microsoft are willing to pay a lot of or hundreds of thousands of dollars to bounty hunters if they can come up with a viable model. Although compromised hypervisor exploits have occurred in the past, this is not a common type of attack. There's a specific CVE 2008-0923. It was released in 2008. And VMware Workstation 6.02 and 5.5.4 are vulnerable to VM escape from the virtual machines. Now let's talk about the following VMware technologies, right, as you see here. The first are containers. Come on. Hold on. Yep. Okay. First are containers, right? So here, workloads can be deployed in the data center more efficiently using containers. All of the application's binary files and library dependencies are contained in a single package called a container. A container-based application's bugs or errors won't affect any other applications because it is isolated from the host operating system. Containers provide a means of separating and encapsulating different programs. So, container security must be taken into account. We must ensure that our containers are isolated from those of other customers if we're utilizing a cloud platform. Deployment and migration are simplified and thanks to containers, right? Which can run to a variety of operating systems and hardware. Because they don't need to run on a virtual machine, they have very low overhead. Now is emulation. So it is possible to run programs, right, and services that would not otherwise be supported on a given platform by means of emulation. Using an emulator to run old arcade games on a modern computer is one example, like this one, right? Instead of connecting a serial cable directly from a terminal to a network appliance, terminal emulators can be used to remotely access another device. If you have a desktop computer, you can run Linux commands by emulating the shell of the Linux command line in the Windows. Next is application virtualization. So using application virtualization, you can support multiple platforms with a single line of business or LOB or legacy application. It is possible to host multiple RDP sessions to a single application that is published on Microsoft RDP services or Microsoft servers. Using a server farm, we could expand to an enterprise, and using this model, we could, for example, run Windows applications on a Linux host. The application can also be streamed across the network and run locally. AppV is the Microsoft name for this technology, while CNAP is the Citrix name for a similar one. Fourth one is VDI, or Virtual Desktop Infrastructure, and it enables the control of compute resources from within a data center or cloud. This is a typical scenario, like an employee logs on to the company desktop via a basic 10 client and runs all of the necessary applications. Now, any device that can run the remote software can be used by the user to access their desktop. Most operating systems can run the Microsoft RDP client. The advantages of this approach include stability, security, and speed of deployment. All right, now let's talk about cloud deployment models. So here, right, cloud computing can be further divided into types as based on service models deployed. Cloud technology is deployed and consumed in a variety of ways, including private, right, public, hybrid, and community cloud. So what are these and what are the differences? So let's focus first on the private cloud. This refers to a hosted infrastructure in a private platform and is referred to as a private cloud. Internal, corporate, or enterprise cloud are some of the terms used to describe it. A private cloud allows organizations to have more control over their infrastructure and is typically only available to employees and business partners. A private cloud or a public cloud provides the ability to add new applications and services on demand. So here, an organization can better manage its data with the private cloud design because the flexibility in the design specifications, better performance, and easier access to compliance data that come with a private cloud, right? And here, building capacity limitations and higher infrastructure, maintenance, and administration costs are some of the drawbacks of a private cloud. Private clouds are ideal for companies that need to maintain strict control over sensitive data, such as those in the financial sector. Right? So that's the private cloud. Now, what are public clouds? So here, right? For a monthly or yearly fee, users can access services and infrastructure hosted at an offsite facility of a service provider via the internet. It is common for multiple organizations to share common infrastructure, but their data is logically separated from that of other organizations. Lower infrastructure, maintenance, and administrative costs, greater hardware efficiency, faster implementation, and the availability of short-term use are all advantages of using a public cloud. Now, reduced bandwidth and less control over data and the environment are all the drawbacks of a public cloud. The downsides of a public cloud include increased vulnerability, right? Because the data transfer capability is limited to that of the internet service provider. When an organization needs scalability and wants to cut costs, and they doesn't have any in-house administrative staff or has high maintenance distributed network, a public cloud is the best option. All right, so we covered public and private. Now we talk about community cloud. So in order to meet the needs of a specific group of businesses, a community cloud was created. It is common for community clouds to be industry specific, such as in healthcare, energy, or government. Using a hybrid cloud, community clouds allow businesses to collaborate in a cloud environment while ensuring a high level of security. To increase across organizational or collaborative processes in the event that in-house implementation is not possible due to conditions such as geographically distributed participants or fluctuating resource requirements, organizations should use the community cloud. Google's use of Google Apps for government agencies is an example of a community cloud. All right, and the fourth one is hybrid cloud. A hybrid cloud is made up of both public and private on-premises infrastructure that is managed by the end users themselves. Data is kept safe in a private cloud while public clouds handle the rest. This strategy enables a company to take advantage of the positive aspects of both work environments. So when a company services needs to be tailored to different vertical markets or have varying needs, a hybrid cloud environment is the best option. Public cloud migrations benefit greatly from the interoperability and scalability that hybrid clouds provide as well. Gateway services make it simple to implement a hybrid cloud approach. Okay? Now let's move on to the next topic, which is about hosting models. So as you may know, right, wealthy individuals can afford to live in a gated community with their own personal security team. A gated community might be an option if you don't have that kind of money, right? So think about community cloud. To save money on housing, consider renting an apartment within a building where you can use the common stairwells and elevators. And there are, however, other choices. So in public cloud, if you pay the cheapest price possible, you're more than likely going to use a multi-tenant model. So on the same hypervisor as other customers, your web servers will be running as a virtual machine. Now, if your database is hosted on the same server as other customers using the same schema, you may be able to share resources, right? And even though single-tenant cloud services are widely available, they're often expensive. Customers can use their own hardware to host their own services on top of the provider's public cloud, and because of this, you can bet they're going to raise the price. Okay, now let's talk about the service models. So the concept of cloud computing can be traced back to the concept of mainframe computing, where multiple users were given a small slices of computers' time to run whatever program they need at the time. In today's world, cloud computing providers typically provide computing resources like computing power, storage, and common applications to customers via the internet, via a web browser or portal. It is a combination of virtualization, distributed computing, and widespread high-speed bandwidth and makes cloud computing what it is. So when it comes to cloud computing, right, the deployment and service models are both used in the layered architecture of the cloud infrastructure. So there's what we call as the, of course, traditional. This is what we know. Then we have IaaS, PaaS, and SaaS, right? These are the three well-known types of cloud-hosted services. So what's the difference, right? So for first one is IaaS. So IT infrastructure as a service is delivered via the internet as part of the cloud-based hosting model. This cloud computing method allows the customers to outsource everything normally found in a typical IT environment. This includes software, servers, DC space, and network equipment. And IaaS is billed based on how much you use, just like electricity and water. As a result, it falls into the utility computing category. Hardware virtualization and internet connectivity are common features of an IaaS or an infrastructure as a service. If you'll see here, right, this means that the cloud service provider will manage this area, the hypervisor, the server, storage, and physical network. However, on top, this will be on the responsibility of the customer. Now, let's move on to the next one, okay, which is PaaS, Platform as a Service. So here, no software must be downloaded or installed in order to use the platform as a service. PaaS systems are often cloud-based development platforms, so developers don't have to worry about servers when using them. PaaS has a distinct advantage in that it enables rapid application development for a large audience. An integrated environment, interface creation tools, and web and database integration are all common features in PaaS solutions that are commonly used. Facebook is a good example of a PaaS because developers can create applications for Facebook using the APIs and tools provided by Facebook. If you look at this illustration, right, so we're actually increasing the scope of the CSP or the cloud service provider up to this portion, up to the middleware. But the data, application, the runtime, this will be still on the responsibility of the customer. Third is SaaS, right? SaaS is a subscription model for software. Clients can access licensed software via the internet and pay as they go for it as a service. To use the online service, all that is required is a web browser and an internet connection. IaaS is used to build the majority of SaaS solutions. A SaaS provider hosts an application and makes it available to customers for a predetermined period of time, after which the application becomes inactive unless a subscription is renewed. Using the SaaS model, individuals and organizations can access a certain application without having to purchase a full license. There are no upfront costs or ongoing maintenance costs associated with this on-demand licensing environment, unlike traditional software purchases. So if you look at this illustration, right, okay, there's more responsibility with the CSP up to the application, but still the data, of course, will be provided or managed by the customer. All right, let's go to the last topic, which is the storage model. Right? Storage models. So the amount of heterogeneous data that an enterprise generates and manages is expected to grow over time. A variety of data will be needed by the finance, marketing, and transportation departments, as well as the company's board of directors, in order to make informed decisions. Because of the wide variety of data types, relying on a single data store is the best choice. So a more efficient way to store data is by spreading or separating it into separate databases tailored to different workloads or usage patterns. As a result, it's important to know the main storage models and their advantages and disadvantages. First one are the file-based storage. So in the traditional client-server model, these files are used to store data. So user map drives can access shared folders on a NAS device or a file server, for example. A hypervisor platform could host VMs of other file types. Next is database storage. So here, two-dimensional tables with rows and columns make up a database, which is referred to as relational database. In order to retrieve and manage data, many vendors make use of SQL, or structured query language. That way, no record is added or updated until it has been verified, ensuring the integrity of the data, right? Now, RDBMS, Relational Database Management Systems, require a schema, which is a list of permitted objects and attributes that can be used in the system. The schema must be used for all read and write operations. Examples of our relational databases include Microsoft SQL, MySQL, and PostgreSQL. Next are block storage. So using block storage, you can organize your data into blocks of a specific size. There will only be a sliver of the data stored in each block. On a SAN iSCSI or fiber channel, this is typically used. Requests are made to find the correct location of the blocks, and the blocks are assembled to form the complete file. Metadata is not stored with the blocks in block storage. Its primary advantage is speed, but this can only be achieved if the application and storage are both locally installed, ideally on a SAN. If the application and the blocks are too far apart, the performance will be negatively impacted. Database applications commonly make up or make use of this type of storage. Next is blob storage. So large binary objects are well suited to objects storage strengths like image files, video, audio streams, large application data, objects and documents, and virtual machine disk images. Metadata tags can be linked to a file in order to improve searching through these repositories. Now, it's possible that this can be customized by the user, like searching through the raw data of a video image would be difficult. It is ideal for large files and data stores because they are very, very scalable. And last one is the key value pairs, right? So in order to store identifiers and values, the use of key value pairs is highly recommended. A rainbow table or any other kind of lookup table can benefit from the storage type. If you're doing a compliance scan, this could come in handy. The database could have a series of identifiers and the actual value that it is expecting to be set in the database. Okay, that's the end of the lesson. Here we spoke about the following: virtualization strategies, cloud deployment models, hosting models, service models, and storage models. Again, thank you very much for watching the video.